Let's take a look at two different methods for solving a quadratic equation. Method 1, we are going to solve a quadratic equation using the square root method. Note, this method will only work if we only see one occurrence of the variable and at the same time the variable is being squared. So your steps are going to be first to isolate the x squared term. So in our equation 10 minus 2x squared equals 0, we're going to isolate the x squared term by adding 2x squared to both sides. This will give us a positive coefficient for our x squared term. Our new equation is 10 equals 2x squared. I still have to isolate the x squared, so I will divide both sides of the equation by 2, leaving me with 5 equals x squared. Now it's time to take the square root of both sides. Remember, if my x value is being squared, that means there's going to be two solutions. This is why you can't forget to use the plus or minus symbol when you take the square root of both sides. Sometimes we like to see x on the left, so I'm going to rewrite it as x squared equals 5. And then when I take the square root of both sides, x equals the square root of 5, but remember, don't forget the plus or minus. So x actually equals the positive square root 5 or negative square root 5, and those would be our two solutions. Method 2, we're going to use the zero product property, and we can only use the zero product property if the expression that we get on one side of the equation is able to be factored. So you want to start by getting 0 on one side of the equation. My hint is to do whatever you have to do in order to maintain a positive value for a. So when you get your equation to look like ax squared plus bx plus c equals 0 and you're ready to factor, it's much easier to factor if that a value is positive. So when I look at my equation 10 minus 2x squared equals x, I know I could easily just subtract x from both sides and then I would have 0 on one side, but then my x squared term would still have that leading coefficient -2. So instead, I'm going to add 2x squared to both sides, and I'm also going to subtract 10 from both sides. So even though that's two terms I have to clear from one side and bring to the other side, it's worth it because then I have a positive value for a. So now on the left side, I have 0 equals positive 2x squared plus the x that was already there minus 10. So that x value that was already there, that's now my middle term plus 1x or just plus x. Now I'm ready to factor. So I want to find two binomials that will be able to get multiplied to get me back to 2x squared plus x minus 10. I'm going to do the trial and error method here. My leading coefficient is 2, so that means I have to start my binomials with 2x and x. That's the only way to multiply to 2x squared. So now, in these two yellow boxes, I need two numbers that will multiply to 10. Notice I'm not doing the AC method here. Since I'm doing trial and error, I need numbers that multiply to 10. So I'm thinking 5 and 2. So I'm going to insert the 5 and the 2. And now I just have to decide if it's a plus 5 or a minus 5, and if it's going to be plus 2 or minus 2. I have to multiply to -10. So one term has to be positive and one term has to be negative. Now, when I think about multiplying those binomials, the terms on the outside will multiply to become 4x, and the terms on the inside will multiply to become 5x. Let me show you that one more time. The outside terms will become 4x, and the inside terms will become 5x. But remember, I just want that to add up to 1x in the middle. So if the 5x was positive and the 4x was negative, I could get it to add to 1x in the middle. So it needs to be 2x plus 5 and x minus 2. Let's just check that off to the side to make sure we agree with the factors. So 2x plus 5 times x minus 2. If I distribute, I'm going to get 2x squared. On the outside, I will get minus 4x, the inside will be plus 5x, and the last two will be minus 10. And then when I combine like terms in the middle, I get 2x squared plus x minus 10. Yes, it checks out. So I'm happy with my factors. So now I'm going to go back over to my problem and I'm going to apply the zero product property. This means each binomial can be set equal to 0, and then that creates two linear equations. For the first equation, I will subtract 5 from both sides and then divide by 2, and I'm going to get my first solution of x equals negative 5 halves. In the second equation, all I have to do is add 2 to both sides, and I get my second solution of positive 2. So my solution set is negative 5 halves, or 2.